You are welcome to a pure mathematics lab. Today we want to talk about, we want to give example on what? On circle geometry. Now look at this diagram. We have a tangent at the point of contact A, the circle what? A, B, C, D, E. The question is asking us to find the value of x, y, and z. We have x here, we have y here, and we have z here. And from the diagram we can see that AE is the same thing as what? DE. That is AE is what? DE. So how can we find the value of x, y, and z? So the first thing I can see here is that I'm having a tangent and I'm having several chords. This is a chord, this is a chord, this is a diameter because it passes the center of the circle, and this is also what? A chord. Now, but I can see that with this chord AD, this chord AD is forming an angle with the tangent 130 degree with the tangent. Meaning that this chord, the angle that this chord is going to form in the alternate segment is going to be the same too. This chord is dividing the circle into what? This is the minor and this is the major. So the alternate segment of the major is going to be what? The minor. And you can see that chord is forming DEA. Automatically what I'm saying is that DEA is also equals to what? 130 degree. And the reason is just because what? Alternate segment of what? Of the circle. Alternate segment. Now if this place is 130 degree, then I can determine this and this. That is what? Because DEA is what? An isosceles triangle. So ADE is equals to what? DAE, which is what? Base angle of an isosceles triangle. Base angle of what? An isosceles triangle. If that is the case, then I can say ADE is equals to 180 degree minus 130 degree over 2. And that will give us what? 50 degree over 2. And that will give us what? 25 degree. The reason for this one is sum of angle in what? In a triangle. Sum of angle in a triangle. Because if this is 130 and this are the same, that means subtract it from 180 divided by 2 is going to give you. So this is what? 25 degree. This is also what? 25 degree. Then that means I've determined the value of x. You can see this is a chord. AE is a chord. All this place is the major. And this small one is a minor. You can see the angle that this chord is forming with the tangent is to be the same thing as the angle that this chord is forming to what? To major segment, which is the alternate segment. Automatically, our x equals to what? 25 degree. Reason, alternate segment. Now, we determine the value of x. What of y? Oh, I can see the cyclic quadrilateral. ACDE. I've explained the meaning of cyclic quadrilateral before. Or ABDE. So what we're saying is that Z plus 130 degree is equals to 180 degree. Reason, opposite angle of a cyclic quadrilateral. So what we're saying is that Z is equals to 180 degree minus 130 degree, which is equals to what? 50 degree. And if Z is equal to 50 degree, automatically y is also equals to what? 50 degree. Y is equals to Z. Y equals to Z, which is equals to what? 50 degree. Reason, same segment. You can see AD from this, AD from this. So they are the what? Same segment. So our S equals to 25 degree. Our y equals to 50 degree. At the same time, our z equals to what? 50 degree. Come back. We want to solve this question too. In this diagram, we have to find the value of w, x, y, and z. But we can see in the diagram that we have a tangent AT. We also have another tangent CT. We have a chord CA. We also have a chord BA with a triangle BAC. Then the question is asking us to find w, x, y, and z. Then how can we solve this simple problem? Since I'm having two tangents from an external point, we've talked about that tangent from an external point are what? Are equal. So CT and AT are equal. CT is equals to AT. Tangents from external points. external point. So automatically what we are saying is that CTA is what? An isosceles triangle. We can determine this side at the same time this side. So we can now say ACT is equals to CAT, which is equals to 180 degree minus 54 degree over 2. 180 degree. And because since this line and this line are the same, automatically this angle and this angle, this angle and this angle are also what? Are also the same. The 180 minus 54, that will give us what? 126 degree over 2. And what's 126 degree over 2? 126 degree over 2 will give us what? 63 degree. So what I said, this way is 63 degree. At the same time, this is what? 63 degree. The reason is because what? Target from an external point are what? Are the same. Now we've determined this place, then I can find the value of x like that. Can you see that this is a chord? It's forming 60 degree with the target. Then it's also forming angle to the what? Alternate segment. Automatically, s equals to what? 60 degree. Alternate segment. Alternate segment. So if this place is also 63 degree, if this is also 60 degree, you can determine the value of y. Since the question it is given that BE is equals to what? BC. Automatically, ABC is also what? An isosceles triangle. Meaning that y is equals to z, which is equals to 180 minus 63 over 2. Listen, base angle of what? Isosceles triangle. With what? Sum of angle in what? In a triangle. So what is 180 minus 63? 180 minus 63 degree will give us what? 117, if I'm not mistaken. 117 over 2. And that will give us what? 58.5 degree. 58.5 degree. Meaning that this place is what? 58.5. And this place is what? 58.5 degree. Now we've determined the value of y like that. So our y is also equals to what? Our z, which is equals to what? 58.5 degree. Now what I'm going to determine w, I can determine w like that. That is w equals to 180 minus z plus 63 equals to what? Sorry, that's listen. The reason is because what? Angle on a straight line. Angle on a straight line. So that means our w equals to 180 minus, what's our set? 58.5 plus 63. And that gives us what? 180 minus what? 58.5 plus 63. That gives us what? 121.5. And that will now give us what? 58.5 degree. See 58.5? See 58.5? Say 58.5 again. 58.5 degree. Yes, correct. 58.5 degree. Meaning that this is also what? 58.5 degree. Then today we've talked about, we find the value of w, x, y, and z in this. If you see any other question that relates to this, you'll be able to solve it. The next time that we're going to meet, I'll move to another, still on circle geometry. We are going to talk about the intersecting chord. We're going to talk about what? The circle, the intersecting of circles in the next class. Till next time that you're going to meet, thank you, wish you best of luck. Don't forget to subscribe, don't forget to like, and don't forget to share. Wish you best of luck.